Let's dive right in. Let's talk about OGCI and transport. How did you figure out the areas that you thought might actually have the most impact?
The oil and gas industry has certain expertise, and our job inside the transport workstream was to try and distill that down into some effective areas where we could really have an impact. And so when we took a look at some of these areas, it really became a focused attention on three primary areas where we felt that the oil and gas industry could offer a unique solution or unique approach. And this is in low carbon fuels. It allows an existing vehicle today to reduce its carbon footprint without the driver needing to do anything other than purchase a fuel that's going to have that lower carbon footprint. Another area we're looking at is hydrogen, whether it's a fuel being directly used by a transport application or being harnessed by a refinery. Another area we're looking at is carbon capture or closing the carbon cycle. The idea of taking a technology and putting it on board a ship and in a very short amount of time finding a way to remove carbon dioxide from those exhaust stacks and making a ship a very low carbon emitting form of transport.
So when you add these three areas together, what's the magnitude of this impact?
Part of the mission of the OGCI is to try and have an impact on a short time scale to really start to put actionable plans in place that are going to have a significant impact on emissions. So we think ultimately with many of these applications, we can get into the hundreds of megatons of CO2 abatement. The challenge is very large. It's an extremely large scale problem to try and tackle carbon dioxide emissions coming from the transport sector. We can't act unilaterally. We've got to engage collaboratively with many of these industries.
So how open are either the manufacturers, the infrastructure players, the governments to this kind of initiative?
We're really finding some enthusiasm and some positive reactions from many industries to the work that we're doing and to the ideas that we're bringing forth. And we're finding some eager collaborative partners inside these areas to work with us and to help define how these actions are going to be put in place.
So Mike, I'd like to ask you what you are most excited about, where you feel that OGCI can have the most demonstrable impact in terms of reducing greenhouse gas emissions.
One of the areas that I'm most excited about is the concept of the synthetic fuel or the e-fuel, taking renewable energy and converting that into a liquid hydrocarbon that can be distributed to today's vehicles. You can imagine that the deserts of the Sahara, for instance, there's a lot of solar radiation available there, but there's no way to get it to the people that need it. So you can imagine a way to take all of that energy and convert that energy into a liquid hydrocarbon fuel. It becomes a very easy way to convert that vast quantity of solar energy into a usable product that anyone can use.
To what extent are we expecting to change the focus of this transport workstream as a result of some of the transformations that COVID and its impact will have on the transport system?
I think that the impact of the COVID-19 pandemic is going to make the work we're doing in the transport workstream even more critical and more urgent. We've really got to concentrate on how we're going to remove carbon from all the different modes of transport and all of the different energy carriers that we're going to use in transportation. So in order to effectively tackle this, we have to use all of the tools in the toolbox.
Kai, can you explain to me what a low carbon fuel is? Because I thought all fuels were basically created equal.
So when we talk about low carbon fuels, we like to put them in three different categories. Firstly, we talk about refinery reformulated fuels. So what we're talking about doing is making a gasoline or a diesel fuel that has a lower carbon footprint. A second case is a blended fuel that contains some different components, which are either very low in their CO2 footprint or potentially zero CO2. We then talk about a third category, which is alternative fuels. Generally, when we're talking about alternative fuels, we're talking about fuels that don't necessarily look like a gasoline or diesel that's in the market today. So for example, one example is hydrogen of a low carbon fuel.
What within this area, this spectrum of low carbon fuels, which of them do you think can have the most impact?
Within these different categories, we can also refer to subcategories. We have drop-in fuels and non-drop-in fuels. So an example of a drop-in fuel is essentially a fuel that meets the existing fuel quality specifications and is compatible with existing engines. So what that means is, if we can get this fuel into the market, essentially you can take your car down to the gas station and you can fill up with this fuel without having any impact on yourself or the operation of the vehicle, and it will produce fewer CO2 emissions. Now, the big benefit of this really is that it's able to leverage the existing installed vehicles that are already in the market. And really, this is a good option to decarbonize those in the short term, because really we can leverage quite a high volume of vehicles out there already in the market and reduce CO2 emissions from those without having to adopt new vehicles and new technologies into the market, which will obviously take some time.
Why don't we just take all of our transport fleet and just move it off of fossil fuels?
It's important to remember the transport and energy supply system we have today has been built up over more than 100 years. There's more than 1.2 billion vehicles, vessels, and aircraft already in operation, and the vast majority of these are using liquid fuels. So really, any transition away from that is going to take some time. I think it's also important to remember that really there's a sense of urgency around the climate debate, and it's important to deliver practical solutions today. So what we can offer as OGCI in the low carbon fuel space, for example, is fuels that we can put into the market today, which reduce the carbon footprint of all of these vehicles that are already out there on the road, and also utilize the infrastructure that has been built up over the last century.
Great. Let's turn our conversation to hydrogen. Can you talk about why it is that hydrogen is yet again a subject of conversation, and why we think it might actually take off, so to speak, at this point? And why is it an area of focus for the transport workstream?
The reason that hydrogen is becoming a more important opportunity for the global transportation sector is because of the heightened attention and scrutiny being placed on the decarbonization of transport. 15 years ago, there were initiatives in place to look at hydrogen, but the intensity of the discussion, the intensity of the debate was missing. And so what we're looking at today is a much different environment, a very different climate, if you will, for hydrogen to play a role. And so the challenge is, can you create and deliver this hydrogen effectively and economically in the amounts needed to have a significant impact? We have a lot of experience in generating, in processing, and delivering vast quantities of hydrogen. And we have found a way to do so in a very safe and effective manner. So we think we can bring our expertise to bear to start to look at how are we going to get this introduced into the market and make it available for trucks or ships or other applications to take advantage of hydrogen.
Can you talk about concerns about safety and why it is we feel now that it's able to be dealt with not at the industrial, but almost at a much more broad scale, at a commercial scale?
Hydrogen is a volatile substance. It's going to cause a lot of people to take a very serious look at how to safely handle it. It can be explosive, it burns very readily, it's sometimes difficult to transport and to effectively run through pipelines, for instance. But we also know that because we have a background in processing and handling it very safely, that it can be done. The challenge is making sure that we take all of the safety protocols and procedures that we've learned in the oil and gas industry and making sure that they're applied effectively, safely, and responsibly in the fueling industry, so that a user, as they bring their vehicle into a refueling station, is able to do so with a full confidence that it's being done in a manner that is going to keep them 100% safe.
So can you talk through what are the big challenges OGCI sees in the adoption and the widespread application around hydrogen? And how is OGCI and the oil and gas sector, speaking more broadly, hoping to address them?
Yeah, there are a number of challenges to delivering hydrogen into an effective refueling system or making it available for transport applications to use easily. First and foremost is simply cost. It costs a lot to generate hydrogen, more so than it does to produce a diesel or a gasoline. So one of the areas we're looking into is how can we scale hydrogen production sufficiently to make it economically viable? And it's not an easy challenge to overcome, but it's an area that we feel we've got unique expertise where we can tackle it effectively. A second hurdle to introducing hydrogen is surrounding the source of hydrogen. Where does it come from? Right now, most of the hydrogen available comes from converting natural gas. So we're looking into what's called blue hydrogen. This is hydrogen that's generated by using that same technique, but capturing the carbon and sequestering that. So overall, you've got a hydrogen source that's got a very low carbon footprint. And then ultimately you want to go to green hydrogen. That is hydrogen that's generated from a very renewable source. Solar cells operating from sunlight, wind power. So ultimately what we're looking at are midterm and long-term technologies that are going to allow us to produce hydrogen in a much more low carbon manner and ultimately get to a point where we can produce hydrogen completely free of any carbon emissions. In our closing the carbon cycle activity, what we're looking at right now is something called mobile carbon capture. Now, carbon capture technologies have been used quite widely around the world, primarily in industrial sites. It's a technique that removes carbon dioxide from the exhaust stack of a process. And it takes that carbon dioxide, isolates it, and then concentrates it and stores it at high pressure. That carbon dioxide can then be taken and stored underground in large old salt mines, for instance, or used to put into oil wells, for instance, to sequester that carbon dioxide. The mobile carbon capture system is taking the technology applied to large industrial sites and miniaturizing it to a degree, making it much smaller, and then applying it to a carbon dioxide source. Engines on ships are very good sources of carbon dioxide where a carbon capture system can be applied. And what we can do is take this carbon capture technology, potentially apply it to that engine, capture the CO2 out of the emission stack, and then store it on board. And when the ship then docks at a port, we then can take it off board and put it into an underground storage location, or put it into a recycling system and convert it back into a product of one kind or another. And that could be a synthetic fuel, or it could be a synthetic rubber, or a plastic, or what have you. But we see a tremendous opportunity to apply carbon capture technology to large ocean-going ships. We think there's a potential there to really remove a lot of carbon in a rather short time frame.
It would require, however, the cooperation of a whole lot of ports. I mean, shipping lines, if you follow the map of where they go, they can easily touch 10, 15 ports in a given period of time. How would you approach working with the ports crews to make this effective?
Yes, absolutely. And you're not going to do this all in one day, basically. It's going to take some time to roll this out and really to make it work. But we're doing some parallel work within our carbon capture and sequestration workstream. In that area, we're launching these Kickstarter hubs, which are regional focused hubs that are looking at the business and technical requirements for capturing large volumes of carbon dioxide, processing them, storing them, moving them around in large quantities. And many of these Kickstarter hubs are located in port facilities or near port facilities. So we see a tremendous opportunity to collaborate and leverage the carbon capture Kickstarter hub idea work with the marine industry and find a way to bring all this together to effectively remove a lot of carbon dioxide from that sector.